Hi, welcome to my demonstration for our application called Pokémote. Pokémote is an application that essentially enacts as a face filter that takes in the facial expressions of its user and gives a corresponding matching Pokemon that has a similar facial expression. So essentially, we're trying to reenact one of those which Disney character are you filter, or which Harry Potter character, which Disney princess you are. But usually those filters work by essentially just the random number generator and gives you a random match. We want to try to do something similar, but instead actually have facial features as part of the decision process. So I'm already recording within my app. That's why you see a red rectangle on my face right now. What I'm going to do is I am going to essentially just run through the app once to show you how this is being how this works, and then I'll explain in more detail as to how this is implemented and the more specifics. So right now there's a red rectangle on my face. This means that it sees a face and it's trying to ask the user if we want to collect data on this face. Now when I press on this rectangle, a who's that Pokemon kind question mark will show up next to my face. Now while that is showing up, that means the the application is collecting baseline data on my face. So when that happens, I am supposed to be making a neutral face. And after a while, after it has collected enough data points about my neutral face, then it will try to make a match. So let's begin. So now we're in the matching stage. I can make some expressions. So right now the matches that they give are not very meaningful. So for example, I can try to do something like this. Or I can do something like this. And lastly, I'm going to try to also do something like this. Okay, so the last one is not very stable, but since the lighting condition that I have here is a bit different from the testing environment that I have, I can't exactly control that. So there are also other Pokemons in the list of Pokemon that we have here that I haven't covered, which you can see more of in a report. But for time's sake, those are the few that I'm going to show you. So now I'm going to go over a bit more in the technical side of things. So the first thing I'm going to do is I'm going to turn on the debug mode of my app. So my screen will freeze for a little bit. Alrighty. So now there's more information on the screen. So I am going to first of all reset my application. To do that, I am simply going to change the camera and then change it back. Alright. So let's talk about what you see in the screen right now. There are points that are on my face that are kind of moving, and they're all enumerated. So these points are given by the FaceMark API in OpenCV. And using these points, we can actually do a lot of interesting things. So you may be wondering, okay, so how did we manage to match the Pokemons with the facial expressions that we have? So one of the things is that we can essentially take polyline representations of specific regions on our face. For example, if I move in a little bit closer, you can see that there are specific points on my eye. For example, I can see 42, 45, 47, 44, 43, 48. So those points added together will form the region for my right eye. And of course, similarly, on my left side, there are other points that will give the region for that eye as well. So for example, if I want to see whether if my eyes were closed, all I have to do is take the area of those regions and then compare it with the area of the regions of the baseline. So part of having a baseline is so if you give the application a neutral face to refer to, then it will be able to tell whether if, let's say, your mouth was open more than before, or your eyes were open more than before, or your eyes were less open than before. So this is essentially how matching Snorlax worked in the original setting. So for example, with the face marks turned on, I'm going to do this again. Now if I close my eyes, there we go. So eyes are one of the more major features that we have here, because we have Pokemon that either have eyes closed, have eyes at a regular level, or have eyes that are open very big. Now, there are some other features that we have. Another one that is pretty obvious is going to be how wide my mouth is opened as. So in a neutral face setting, people are not supposed to open their mouth. So that means the area of my mouth region is going to be not that big. So if I move my face closer and just point at the points here, you see that some of those points here actually overlap each other. So essentially, when a mouth is open, those points will not overlap each other. So I'm going to do this again with my mouth open. There we go. So with the mouth open, we also have specific Pokemon that matches this trait, and we can use that as a way to guide whether if a Pokemon that will be matched is going to be this one. Now there are two other features that we have. The first one is to determine how thick someone's lips are, because we have some Pokemon with very thick lips. So this works in a similar way as the other two, where I take the area of my lower and upper lip and then I compare that with the area of the lower and upper lip in the baseline. So this one is a little bit more debatable because people might have fatter lips than other people, but essentially to imitate the size of someone's lips or to imitate a difference in thickness of lips, it's just a matter of showing however many lips. So you can have lips that are more inside and lips that are more outside. Okay, and now one last feature that I will talk about is essentially a distance between the nose and the bottom of the lips. So that means from this point here, which OpenCV tells us is 0.33, the bottom of my nose here, and the bottom of the lips. So here is 57. So essentially, this one right here, if I have it so it's very long, then that means your lips here, this distance is going to be long as well. So one of the Pokemon that we have matched before, called Grookey, he has very long lips, or a very long top lip, because he is like an ape. So for example, so right now I've frozen the frame and it's going back and forth between Grookey and Snorlax right now. The reason why it's confusing it as Snorlax is because the lighting condition is not very good, so it's not very easy to tell how open my eyes are. But that's the general gist. And that essentially wraps up what I have for this application. So one of the main challenges was making this application is that we need to essentially establish how different a facial expression is from a baseline. And we see that these key points here, they're kind of jittering around. So how to make that more stable and how to tell the difference is going to be left as future work. And for now, what we did is we simply have this tuned specifically towards different users. So in the final build of this application, it's going to be tuned with my group mate Melanie. And for this demo version, I just simply have it tuned towards a few Pokemon so I can demonstrate. So there's one last feature that I do want to show in this application, which is a little Easter egg. So I'm gonna turn off the debugging features first. Okay, well, I guess I accidentally turned on the feature without turning it off, but let me turn off the debugging features again. So as you can see here, the application actually takes away my eyebrows, and this is just a little fun thing that we did on the side because we were working on this on Easter, and instead of going egg hunting outside, we decided to make a new Easter egg in our application. But essentially, the eyebrows here, they are guided by the face mark points. So if I turn this on again, you can see that the eyebrows, they essentially match where the face mark points are on my face. And one issue with this is that if I raise my eyebrows, then it's a little bit slow to track. Now, the place that I'm filming this at is pretty bright, so we can actually see everything. But if it's in a dark environment, it's very easy the case that you can actually have the eyebrows not being overwritten. So this concludes the demonstration of the application. Thank you for watching.